4, we are going to learn about the slope of a line. So the slope of a line that is caused when connecting or passing through two given points. The slope of a line is the ratio of the line's vertical change, called the rise, to its horizontal change, called the run. So vertical change is going to be, whoops, let me get my pen here. Vertical change, how far it goes up or down, to its horizontal, which is going to be left or right. So first of all, if we were using a real world situation, we talk about a wakeboard ramp. A wakeboard ramp has a rise of 6 feet and a run of 10 feet. So rising, it goes up 6 feet. Running, it goes 10 feet. So if I was going to write that, I would write it 6 over 10, which is a fraction, and I can always simplify my fraction. So I would say that the slope of this line, let me change to a different color. The slope of the line, that would be right here, or close to that. The slope of this blue line here is going to be 3/5, meaning I can find any of the other points on this line by rising 3 or going up 3 and going over 5. All right. So we have different kinds of slopes. There's some pictures here for you to remember them. A positive slope, just the same way, think of this as the same way as if you're reading. When you read a line, you go from left to right. So if I was walking along here from left to right and I hit this line, it's a positive slope. I am going up. If I'm walking here left to right, I'd run into the bottom of the hill. I'd have to run here and then go this way. That would be a negative slope. Okay, this you don't find often in Dubuque, but if I had just a straight horizontal line, that would mean there's no slope in it at all. That would be a 0 slope. And there's no way to climb straight up or straight down. It would be like just some Star Trek special effects there. So that would be called an undefined slope. So the slope of a line is when you're given 2 points on a non-vertical line, because that was the impossible slope. You can find the slope of the slope, which we are going to refer to as m, of the line using this formula. M, which means slope, equals the rise over the run. So we're going to look at these 2 points, 1, 2, and 4, 5. And it says the rise is the difference between their y coordinate points. So I'm going to go ahead and I'm going to label my points here, the x and the y, and the x and the y. So if I want to find the difference means subtraction, and you're going to learn when you see it in the algebra book, they usually go from the second set to the first set. So I'm going to get you used to that. So sometimes you'll see the formula written like this. Y2, you can read my 2, minus y1, that's the second y minus the first y, over x2 minus x1. So I'm going to go ahead and do it that way because that's the way you'll see it in most textbooks. So my second y in this set of coordinate points is 5, and I'm going to try to rewrite that. That got kind of silly on me. Let me try doing that again. The second y here is going to be 5, much better. My first y is 2. I'm subtracting them because I'm finding the difference. Now the thing to remember with this is whichever point you start with, you need to do the same thing when you're finding the differences between the x's. So I started with the second point here, so I'm going to take that x, which is 4, and I'm going to subtract the first x, which is 1. When I do this, I get 5 minus 2 is 3. I get 4 minus 1 is also 3. Now, we can reduce that to just 1, but again, we talked about slope, m, equaling, slope is m, equaling rise over run. So I can still write it as a fraction. You should write it as a fraction, 1 over 1. So that means I would go up 1 unit and over to the right 1 unit. For each one of the points I would find on that line, the difference between them would be going up 1 and to the right 1. So let's see that. I'm going to go ahead and I'm going to plot these points. So my first point is 4, 5. So I'm going to go over here, over 4, 1, 2, 3, 4, up 5. Okay, my next point is going to be at 1, 2. Whoops, and grab my point here. So over 1, up 2. Now I'm going to take my, if I can get my line here. Doesn't want to help, doesn't want to go with it. Let's see if I can do it on the screen instead. There we go. So if I take my line and see if I can make it go through both lines, or both points, sorry. You know, this takes a little bit of tweaking here. So we'll get it through my points. There we go. So now I graphed those points, and I want to find the slope of that line. The first thing I'm going to notice is that it is a positive slope. If I'm walking across that grid like I was reading it, from left to right, I would have to go uphill. So that's a positive slope. The next thing I can do is go ahead and calculate the rise over the run. Again, the rise was the difference between the y coordinate points. So I went ahead and did 5 minus 2. And then since I started at that top one, I used the top one again. So the difference of the x is 4 over 1. Now I'm going to show you that with these rise and run arrows here. So rise, if I went from this point right here to my other point that I used, I could go up 3. So 1, 2, 3. I need to make this a little bit smaller here. So I'm going to go up 3 units. 1, 2. Gotta make it smaller than that. There's up 3 units. And now I'm supposed to be able to run 3 units. So let me see if I can grab my red running line here. And if I run 1, 2, 3, I land at, oops, sorry. I land at my other point. Now, when I went ahead and when I reduced that, I came up with 1 or 1 over 1. So that's the simplified version. You should always have the simplified version. And I'm going to go ahead, let me see if I can put this one right next to it if you can see it. If I went up 1, oopsie, you know what? That's going to be too hard. I'm going to just take this one. I'm going to go, this time I'm only going to go up 1 unit. There's up 1 unit from that first point. And this time I'm going to run 1 unit. And you can see I land on the line. Now let's see if I can do a little bit of trickiness here. And I'm going to copy that and I'm going to paste it in a couple other places. So let's see, except for I didn't group them. So let me undo that a couple times. I should have grouped them first. Move back to my running 1. Okay, and I'll select my rising 1. And the first thing I'm going to do is group those. And then I'm going to copy them. So let me now copy that group. And now let's give me a couple of those. Paste and paste. I'll do one more. All right. So let me get the extra ones out of here 1 minute. All right. So you can see I still have my original up 1 over 1. Now if I went from that point, and I'm going to take another up 1 over 1, and you'll see that lands directly on the line. I can do that again, which got me to my first point that we calculated at up 3, or rise 3, run 3, and it will work for every single one of those points on the line. Okay, so that would be that the slope is a positive 1. Going on to the next points, we have the coordinate points 3, -3, and 0, -1. So let's go ahead and plot those. I'm going to go over 3, and I'm going to go down 3. This time I'm going to go over 0. That means I don't move left or right, but I'm going to go up 1. I'm going to go ahead and draw my line, or at least position my line here. Ooh, that came close. That looks like it's going through both. Make it a little bigger here. Okay, a good check is to always look and see. That would be what kind of a slope? That would be a negative slope. Again, if I'm traveling from the left to the right, I'm going to go down the hill. So that's a negative slope. Now let's go ahead and figure out the actual slope of that line. So the difference between the y's, and I'm going to use this point first, -3 minus 1. See that right here? It's always the difference. 3 minus 0 is my difference between my x's, and I get a -4/3, which is what my slope is showing me right here. So let's go ahead and let's check that. Now, if it says it's a -4/3, I can either rise negatively or run negatively, because it just means that that fraction is going to be a negative fraction. So let's go ahead and do it the same way that it says on our calculated slope there. So actually, I'm going to turn my slope around. We said it was a negative slope. So from this point, I'm going to go down 4. So 1, 2, 3, 4. Now, since I came down 4 and did a negative there, I'm going to do a positive for my run. 1, 2, 3, and you see I land right on that point. Now, another way that you could do that is I could go ahead and I could -4/3 could still mean, and this usually just depends on how much room you have on your graph. I could rise 4, so the 4 would be the positive part of that fraction. 1, 2, 3, 4. Get that one down here just a little bit. And because I did the rise, the positive, I'm going to run negatively. So run to the left. And let me see. I want it to be 3 units. So I do that. And you'll see I also land on the same line, a point on the line. So you can either rise positively and run negatively, or rise negatively, that sounds kind of funny, and run positively. One of the rise or the run needs to be negative in a negative slope. The next slope we're going to look at comes from the point 1, 3, over 1, up 3, and 4, 3, over 4, up 3. Now you're going to notice this one is a horizontal line. So that means it's nice and flat. No slope to this line. So when I go ahead and calculate, 3 minus 3 would be 0. 4 minus 1, the difference with the x's, is 3. So 0/3, so you ate 0 pieces out of a pie that was it had 3 pieces. So that's still something that is possible. You could just look at the pie and not eat any pieces, so 0 out of 3. So that would be equal to a 0 slope. You're not going to rise or run. Okay? So I'm sorry, you're not going to rise. So I came from this one, I didn't rise any, but I'm going to run 3. And I could keep running 3 in either direction, because that one's a horizontal line, the slope of that one. The next one, 2, 3, over 2, up 3, and over 2, down, because it's a -1. Now, if you remember, this is the vertical slope, whoops, which is impossible. We can't just shoot up to the sky, and we can't just go down either. That's a good thing. So this time, notice though, I want you to look at the calculations here. When I'm going to the top point, my top point here is, oh, why do I have a -3 on the bottom? Let me see if that was a mistake here from the book. It is. This should not be a -3 here. Let me see if I can white that out. Kind of letting me there. There we go. Okay, so if I take my y point, or my y location of 3, now I'm going to subtract a -1. So when I say 3 minus a -1, remember then we would change that to add the opposite, so we would have 3 plus 1. Be careful with that. That's your integers again. We've been working with these all year. So 3 minus a -1 is the same as saying 3 plus 1. And that's where we get 4 for our numerator. Now when we subtract our two x points, it would be 2 minus 2, which is 0. Now there's no way for you to eat 4 pieces of pie if the pie was cut into 0 pieces. There's not any pies there. So that also makes, or any pieces there. That also makes that impossible. So this would be, it is an undefined slope because it is not possible. Let's see, I think we have one more. We're going to go back to the wakeboarder. And this time he's recorded 2 distances while traveling. In 2 seconds, he traveled 52 feet. And you can see that with our first coordinate points. And then in 7 seconds, he was able to travel a total of 182 feet, which is represented in our second coordinate point. The slope of the line gives the wakeboarder's speed, which is the rate of change in distance traveled with respect to time. So if we went ahead and we set that up with the difference, we're going to find out slope again, differences of the y coordinates over the differences of the x coordinates, we're going to see 182 minus 52 for our y coordinate points and 7 minus 2 for our x coordinate points. So that means his rate of change was 130 feet over 5 seconds. And again, we can reduce that. 5 will go into that evenly. And we can get his rate of change as 26 feet per second. So we could put that into a real world situation. Now you will notice in real world situations, when you go to graph them, they will have to be on just a line graph for the most part. They cannot be on a coordinate grid because you cannot move negatively, or can you change negatively in a real life situation. So normally this would be represented on a graph that looks like this with just the first coordinate, and you would see the graph going like this. And that concludes lesson 8.4, slope of the line.